In this video, I'm going to talk about comparison properties of definite integral. So let's say you have a function f of x, which is greater than or is equal to 0 on some interval. Okay, let's call it a comma b. Okay, then we are going to have integral a to b f of x dx is going to be greater than or is equal to 0. Property number 2, if f of x is greater than or equal to g of x, f of x is greater than or is equal to g of x on some interval a comma b, then integral a to b f of x dx is going to be greater than or equal to integral a to b g of x dx. And number 3 is kind of like bounded property. So let's say you have a function f defined on interval a comma b closed interval and is bounded below by little m, okay, f of x, and bounded above by uppercase m on in the interval a comma b. Then what we are going to have, then m times b minus a, m times b minus a is less than or equal to integral a to b f of x dx is less than or equal to uppercase m times b minus a. And this is pretty easy to show. I can take the integral of just this of all sides with respect to x. Integral m dx is less than or equal to integral f of x dx, which is less than or equal to integral uppercase m dx, and all of these integrals are from a to b. Then by one of the properties, we know that this is going to be m times b minus a, which is going to be less than or equal to integral a to b f of x dx is less than or equal to uppercase m times b minus a. Let me give you an example here to help you out. So let's say you have a function f of x is equal to e to the power x. Okay, we want to find the value of this function on the interval, let's say integral, on the interval between 0 and 1. We know that e to the power x is strictly increasing function. So now in the interval 1 comma 0, the lowest value is going to be e to the power 0, which is 1, and the highest value is going to be e to the power 1, which is just e. So we can say that 1 is less than or equal to e to the power x, which is f of x, is less than or equal to e in the interval 0 comma 1. Now I can integrate all of it. Integral from 0 to 1 dx is less than or equal to integral 0 to 1 e to the power x dx less than or equal to integral e dx 0 to 1. Now this is going to be 1 times 1 minus 0, which is 1. So 1 is less than or equal to integral 0 to 1 e to the power x dx is less than or equal to e times 1 minus 0, which is e. So the integral 0 to 1 is bounded below by 1 and bounded above by e. So the properties that I talked about here are basically 3 properties. So if f is non-negative, meaning 0 or greater on some interval, then the integral will be non-negative, meaning 0 or greater. If f of x is greater than or equal to g of x on some interval, then in that interval, integral of f is greater than integral of g. And if f is bounded below by lowercase m and bounded above by uppercase m on the interval a comma b, then m times b minus a is less than or equal to the integral of f on that interval, which is less than or equal to uppercase m times b minus a, the interval length or the distance. I hope that this discussion was helpful. Thank you very much.